find the geometric mean between each pair of numbers. So the way this would get set up is 8 over x equals x over 12, and then use cross multiplication. 8 times 12 is 96, and then the last step is to take the square root of both sides, and x equals 9.8. Yes, it was in the beginning of the chapter. I realized some of this was like a good 2 weeks ago, so yeah. Okay, next one, it says write a similarity statement to identify the 3 similar triangles. As you know, there is a triangle right here, small one, and there's also a triangle right here, and then the larger triangle that encompasses the whole thing. Where's my other highlighter? There it is. Okay, so 3 triangles here, this one, a medium-sized one, and the larger one that encompasses both. Okay, similarity statement. When you make the similarity statement, you have to make sure that you're naming the sides in the same order. So if I'm going from short to medium, so I could say triangle JML, then in my similarity statement, the next one I have to name like short to medium as well, LMK. And then that is similar to the larger one, again, short to medium, so JLK. And as you're looking through the answer choices, you're just making sure that it's the same order. So if they did medium then short, they would need to do that every single time. Okay, next question. Okay, these ones. There's different ways you could do this. Remember, there's similar triangles, so you can set up the ratios that way. First off, 25 and 6 right here. I'm going to do 25 minus 6 to get 19 as this distance. And one of the things we learned in this chapter is you can find the geometric mean of 6 and 19 to find this length. So 6 over x equals x over 19, and I'm going to set that up. And then I'm going to solve for x. Oh, it's on the back table, Wilson. Thank you. X times x is x squared. 6 times 19 is 114. And then square root of this, and x equals about 10.7. So starting there. Okay, at this point, yes, you could set up ratios to find z and y, but I think the easier way to do this would be to use Pythagorean theorem. These are right triangles, so you can do a squared plus b squared equals c squared to find z, and same with y. 6 squared plus 10.7 squared equals y squared to find y. So that's what I'm going to do over here. I'm going to find this one first. 19 squared plus 10.7 squared equals z squared. So we got 21.8, and oh yeah, it would, sorry, my bad. And then for the other one, same thing, Pythagorean theorem, 6 squared plus 10.7 squared equals y squared. And then 10.7 squared, just calling it 114. I rounded this, so yeah. For this one, It's a little bit more complicated because we do have to use the similarity between these two triangles in similar parts. So I'm looking at what I have and what I can solve for. On the larger triangle, I have short to long. So short to long on the longer one. And then right in here on the smaller one, I also have short to long. So I'm going to use that to set up my ratio. There's more than one way you could do this, but that's what I saw right away. So short to long, so I'm going to do 10 over 20 equals short to long on this one. So y over 10. And then use cross multiplication. 20y equals 100 and y equals 5. Then from there, I can see that this is 15. And then to find z, kind of seeing what I have. How did I do it over here? Oh, I used Pythagorean theorem to find z. So we have two sides here, and to find the third one, so this would be your a and b, and then this is c. So 10 squared plus z squared equals 20 squared. Moving down to the next couple problems, these are just Pythagorean theorem. As you know, Pythagorean theorem is a squared plus b squared equals c squared. If you have two sides of a right triangle, you can use this to solve for the third side. So this would be your a and b, and then your c is the hypotenuse. So 13 squared plus 23 squared equals c squared. $26.4. And then for the next one, same idea, Pythagorean theorem. These two sides right here are going to be our a and b, and then this is c. So x squared plus 21 squared equals 34 squared. And then, of course, just make sure that it's logical with the numbers that are given there. Okay, up to the top. Okay, this one you saw on Khan Academy quite a bit. This is also, we're going to use Pythagorean theorem for this, but it shows an isosceles triangle. With that, this altitude splits this part in half. So this would be 9 and 9. And now the right triangle is just like half of it. And we're just trying to find this length right here. So we're going to use Pythagorean theorem. It would be x squared plus 9 squared equals 26 squared. All right, square root both sides. X equals... Oh wait, why did, sorry. X squared equals 595. Then take the square root of both sides and you get x equals 24.4. Next. Okay, so determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, obtuse, or right, and justify your answer. Okay, so first of all, it wants us to classify whether it's a triangle or not. If the two shorter sides are greater than the third side, then yes, it is a triangle. So we can say that's a triangle, and we'll stop there. Then for classifying it as acute, obtuse, or right, if it's a right triangle, notes off to the side. You might want to write, well, I would write this as well, so you have it for the test. A squared plus B squared equals C squared if it's a right triangle. If it's an acute triangle, then A squared plus B squared is greater than C squared. And if it's obtuse, then A squared plus B squared is less than C squared. Okay, and then using that as a guide, we're going to determine whether these are acute, obtuse, or right. So here, 10 squared plus 11 squared, how does that compare to 20 squared? 100 plus 121 compared to 400. Well, 400 is definitely greater than those two, so therefore this is obtuse. Then for the next one, 5 square root of 2, if you were to plug that in a calculator, it comes out to 5 square root of 2 is about 7. If you were to add that to 10, you'd get about 17. And 17 is definitely greater than 11, so yes, it is a triangle. I'm going to use a different color. So yes, this is a triangle. And then we have to do 5 square root of 2 squared plus 10 squared. How does that compare to 11 squared? And as far as this goes, you could do this by hand. Square root of 2 times 5 square root of 2 would be 25 times 2, which is 50. And 50 plus 100 is greater than 121, so this would be acute. Okay, and number 10, 65 plus 72, is that greater than 97? This comes out to 137, definitely greater, so yes, it is a triangle. And then 65 squared plus 72 squared, how does that compare to 97 squared? 9409 equals 9409, so this is a right triangle. Set of problems. Now we're starting the special right triangles. We start out with 3 of the 45, 45, 90. So just making a little note. First special right triangle is this one, and it's 45, 45, 90 degrees. And for those triangles, it would be the two legs are the same measure, and then the hypotenuse is x squared root of 2. Okay, now on this one, we're given a leg. We need to figure out the hypotenuse. So multiplying by square root of 2, we get 14 square root of 2. Then number 12, we have a leg. To find the hypotenuse, we multiply by square root of 2. So 22 square root of 2 is the answer. Then 13, to go from the leg to hypotenuse, multiply by square root of 2. So the answer is 88 square root of 2. Next type of problem is a special right triangle, the 30, 60, 90. So making a little cheat sheet. Here's a 30, 60, 90, meaning that this is a 30-degree angle, this is 60. And then as far as the side goes, this is the short side. The hypotenuse is 2 times the short side, and then the medium side is short times square root of 3. Okay. Then, so in this example, we are given the short side. To go from short to the hypotenuse, we multiply by 2. So this would be 18. And then from short to the medium, we multiply by square root of 3. So this is 9 square root of 3. Okay, next, or not yet. Okay, up to the top, another 30, 60, 90. You could also use trig if you wanted to figure these out. I don't know if you realized that. Okay, so another 30, 60, 90. So this would be 30, this would be 60. And then you have short, 2 times the short times square root of 3. So we're given the short side. We need to multiply that by 2 to get this. And then to go from here to here, multiply by square root of 3. So we get 20 square root of 3. Okay. Now we're going to do trig for the rest of the page. So it says find x, round to the nearest hundredth. Okay. So for 16, we have our angle right here. We have the opposite and adjacent. We're going to need SOHCAHTOA. So with opposite and adjacent, I'm going to be using tan. Tan of 64 equals x over 11. Then to solve, multiply both sides by 11. 11 tan of 64 equals x. You would plug it into the calculator, however your calculator works, and you get x equals 22.55. Okay. Next one, angle, hypotenuse, and adjacent. So now we're using cosine. Cosine of 41 equals x over 32. Multiply both sides by 32. And x equals, once you plug it into a calculator, 24.15. Okay, so use a calculator to find the measure of angle B to the nearest tenth. So now we're finding the measure of the angle. So the angle is x. Based on this angle, we have hypotenuse and adjacent. So based on SOHCAHTOA, we're going to be using cosine. So cosine of x equals 25 over 30. And since we're finding the angle measure, we need to use inverse. So cosine to the -1 or second cosine in the calculator. And it comes out to x equals 33.56 degrees. (19) Same thing, use a calculator to find the measure of angle B. B is right here, that'll be our x. We have hypotenuse right here and adjacent. So we'll use cosine again. Cosine of x equals 7 over 39. You would use second cosine again. And it comes out to x equals 79.7 degrees. And last but not least, number 20, find x to the nearest tenth. Okay, We have an angle here, opposite, and hypotenuse. So therefore, we are going to use sine. Sine of 67 equals x over 20, like that. Multiply both sides by 20. And x equals 18.4. Of course, make sure it's logical based on that triangle. And you're done.